Now Carlos is setting up the GloboTicket infrastructure project. This project rests on top of the domain project and brings in storage concerns. As he does so, he will follow a couple of best practices. He will keep the database configuration separate from the application domain, and he will keep migrations separate from the model. These practices are focused on separation of concerns. The GloboTicket.infrastructure project has a reference to Microsoft.EntityFrameworkCore.SQL Server. The purpose of this project is to set up infrastructure components like SQL Server. And so Carlos has added an extension method called addInfrastructure, which adds these components to the iService collection. In this extension method, he adds the dbContext GloboTicket context. To configure SQL Server, he sets up some options. This is where the generic dbContext options comes into play. In here, he can configure the dbContext to use SQL Server. He's deliberately doing this outside of the dbContext class in order to keep the database configuration separate from the application domain. This is also where he specifies the connection string, and so he adds that as a parameter to the addInfrastructure method. And now he wants to set up some SQL Server specific options. In particular, he sets the migrations assembly. This allows him to keep migrations separate from the model. The model is in the domain assembly, and the migrations are in the infrastructure assembly. And with that, Carlos has kept all of the infrastructure configuration separate from the domain. Now he just needs to call addInfrastructure from the API project, and he'll be ready to go. Now Carlos is adding the API project to the solution. He's not yet focusing on adding controllers and endpoints. Right now, he just needs to configure dependencies at the top level. As he does so, he'll be adding a connection string to the configuration, and so he remembers to never check secrets into source control. Carlos has created a GloboTicket.api project. Now he needs to add services to the container. And so he calls the addInfrastructure extension method on the service collection so that he can configure dependencies at the top level. The extension method takes a connection string. Carlos reads the connection string from configuration, and he gives it the name GloboTicket connection. Now he just needs to add that connection string to appsettings.json. And he puts it in the connection strings section. Here he pauses to consider his security best practices. Never check secrets into source control. To follow that best practice, he uses a connection string that does not contain a password. Instead, it sets trusted connection to true so that it inherits the user's credentials. He knows that there's more work to be done here, but this is a good starting point. We'll cover other security best practices in the next module. And now, Carlos has a solution that is nicely separated. The top layer configures the services, the infrastructure layer adds SQL Server configuration, and the domain layer houses the dbContext and the entities. Carlos prefers to define the dbContext in the domain layer, but some of the Entity Framework mapping configuration needs to be in the infrastructure layer. How is it going to get dbContext to call that mapping configuration? That would be a call up the stack. And so Carlos applies the dependency inversion principle. Dependency inversion is the practice of depending upon an abstract interface rather than a concrete implementation. He adds a shared kernel project at the bottom of the stack. This project contains base classes and interfaces. The domain layer can call those abstractions, and the infrastructure layer can implement them. This new layer lets him follow a couple of additional best practices. Invert dependencies to defend separation of concerns, and rely upon the IOC container to satisfy those dependencies. The IOC, or inversion of control, container is a mechanism for resolving dependencies. It knows that dbContext in the domain layer requires an interface, and it knows that a concrete class in the infrastructure layer implements it. most of the Entity Framework configuration that you'll need is unrelated to the persistence mechanism. It describes and constrains the model. The name of a venue is always required, and the address is optional, no matter how it ends up being persisted. The maximum lengths are 100 and 300 respectively, and these constraints are not about storage, they're about data type. Just think about how you also have to implement these constraints when you're dealing with validation and user interface, which have nothing to do with SQL. These configuration settings are available in the Persistence Agnostic Entity Framework Core package, but the settings that have to do with mapping to a database are not. For example, to map the venue type to the venue table requires a SQL-specific mapping configuration. Likewise, specifying a column type is a SQL-specific setting that requires the SQL-specific package. If, like Carlos, you prefer to have your configuration in the domain layer, then you don't have access to the SQL-specific package. Carlos has added that package to the infrastructure layer. And so, he defines a venue configuration class in that layer as well. Inside of this venue configuration, he adds the persistence mapping configurations. He defines the table mappings, and he sets the column types. The persistence agnostic configurations remain in venue configuration that's still in domain. He has separated the configurations that depend upon the persistence mechanism from the ones that more generally describe the model. The persistence mappings are only valid when he's using SQL Server. But the model configurations are always true, even when he's testing outside of SQL Server. Now the problem is, how does Carlos get Entity Framework to use this configuration class in addition to the one that's in the domain project? He needs to call apply configurations from assembly inside of the DB context on model creating. But the DB context belongs to the domain project, which is one level down. So how do we get a low-level component to call a higher-level component? That's dependency inversion. Carlos will invert his dependencies so that the domain project can call the infrastructure project. To do that, he creates a new project called globoticket.sharedKernel. In this project, he creates an interface called iModelConfiguration. This interface will let a concrete implementation supply additional model configuration to the model builder. The model builder class is defined in the Entity Framework Core package, and so Carlos moves this package dependency down to the shared kernel project. And now we have an abstraction inside of shared kernel. The infrastructure layer will implement this interface, and the domain layer will call it. And so Carlos adds the call to the domain layer. Inside of the globoticket context, he adds a model configuration, and he injects it via the constructor. Now he can call configure model after he has already applied the infrastructure agnostic configurations. The domain layer depends upon an abstraction. Now he needs a concrete implementation. For that, Carlos adds a SQL-specific model configuration to the infrastructure project. He just applies the configurations from the infrastructure assembly. And then, to inject the SQL model configuration, he relies upon the IOC container. He registers a singleton that implements iModelConfiguration using the SQL model configuration class. And with that, Carlos has inverted his dependencies. The domain project depends upon an abstraction defined in shared kernel, and the infrastructure project implements that abstraction to supply SQL Server-specific details at just the right time. Now that Carlos has a layered architecture, he wants to start writing some tests. He begins by unit testing against the domain layer. The domain layer contains entities and, as Carlos prefers, the DB context. It also contains domain services, which are business components that help us bring entities together. He wants to unit test these domain services, but not Entity Framework. Entity Framework already has enough tests. He wants these tests to be fast and easy to change, so he needs a way to isolate the code under test, the domain service code, from the persistence details. One way to isolate code under test is to implement fakes. Fakes provide a predetermined behavior for external components like web services. But Carlos doesn't want to fake Entity Framework. You see, part of the domain service logic is a set of LINQ queries. If he created a fake for Entity Framework that always returned the same data, then he would not be properly testing those queries. On the other hand, Carlos doesn't want to unit test against SQL Server either. That would make tests slower and more cumbersome, and distract him with persistence details while he's trying to get the domain services correct. He'll save the persistence testing for integration tests, which we'll cover in an upcoming module. Instead, he'll configure Entity Framework to use the in-memory query provider. This is a full query provider capable of executing LINQ queries. It doesn't replicate all of the behavior of SQL Server, but for these tests, he doesn't need it to. And so, he brings in the EF-Core in-memory package. Carlos uses the in-memory provider in order to make sure that his tests cover the LINQ queries in his domain services, while still being fast. Carlos adds the unit test project to the solution. He tests against the domain project so that his tests do not depend upon the storage technology. Instead of configuring the DB context to use SQL Server, he will use the in-memory query provider. He'll take steps to isolate his tests from one another so that no test passes or fails because of another one. Carlos has created an XUnit test project called globoticket.unittest. He's already started a test for the promotion service, which he has defined in the domain layer. The promotion service constructor takes a globoticket context, and so he initializes one here. The globoticket context, in turn, takes a DB context options. To create a DB context options, he uses a DB context options builder of type globoticket context. When he accesses the options property, he gets a DB context options of that generic type. And now he wants to use the in-memory query provider. The project already depends upon the Microsoft.EntityFrameworkCore.InMemory NuGet package, which gives us access to the useInMemoryDatabase method. This method asks for a database name. If Carlos uses the same name every time he initializes a test, then the tests will depend upon each other. Any entity that he puts into the database in one test will still be there in the next one. He wants to be sure that the tests are isolated from one another. A test should not depend upon or fail because of data left behind by some other test. And so Carlos uses GUID.NewGUID to create a new database test name for each test run. Now that Carlos has a promotion service initialized with a DB context backed by an in-memory database, he writes his first test. Now he runs the test, and it passes. The promotion service under test uses the DB context, and that DB context is initialized using a brand new in-memory database each time, so that the tests are both fast and isolated. Carlos has defined a layered architecture for his solution. This architecture kept the domain knowledge separate from the infrastructure knowledge. It puts domain below infrastructure so that the business logic doesn't end up implemented in the data access layer. At the top, the API tier wires up the configuration, and at the bottom, the shared kernel provides base classes and interfaces for inverting dependencies. By applying best practices, Carlos has grouped concerns that are highly correlated. Things that change together stay together. He used the project structure to manage dependencies. Since the domain should not depend upon the storage technology, the domain layer does not depend upon the infrastructure layer. With this structure, Carlos can test at incrementally higher layers. He wrote unit tests against the domain layer using the in-memory provider in order to cover all of his query logic. In creating this intelligent project structure, Carlos has set his team up for success. They have a simple yet flexible architecture that puts each decision in the right place.